Hello, my name is Michael Lam, and this is Danielle, and this is James, and we're from the Immersive Visualization Lab in the Architectural Studies Department. And when me and James were undergrads, we did a lot of different types of visualizations here with our friend Paul Bilger. I was never the best sketcher, Paul was never the best model builder, but we were all really good at computer modeling. And so we decided to see if we could take this to the next level and really put ourselves inside of our design. And eventually this would lead to the development of the iLab.
So the iLab was a project that we started back in 2009, and it was a group effort by a group of us graduate students and a few of our faculty members who got together and brought our expertise in virtual reality technology together to obtain a series of internal research grants. Now these grants allowed us to invest in affordable technology to build our own virtual reality system that is very comparable to some of your high-end visualization systems like cave systems. As of today, with the help of several more research grants, we now have a wide variety of 3D hardware and advanced software, ranging from AutoCAD type softwares to gaming technology to other types of virtual reality systems. The iLab mission statement is very simple. We're interested in how advanced immersive visualization techniques can be used to enhance design thinking and collaboration. And we do this by being able to integrate off-the-shelf type of state-of-the-art technologies. And we collaborate with interdisciplinary groups. So we have interdisciplinary teams that come together, and we use their domain knowledge and we borrow their techniques to help further enhance our architectural design. But in turn, we're also able to share our own techniques in the findings that we get from our collaborations to share with other disciplines. So James is going to start talking about some of the work that we've been working on.
Visualization is a very important aspect of architectural design. This is a project which 5 students, 2 of which Mike and I were part of the group, and we try to conceptualize the prison of the future. This is part of an international competition which we submitted, and the proposed concept was to create a more sustainable, rehabilitating facility rather than the ones we traditionally know, such as Alcatraz. This was a reinvention of Alcatraz. When you work at a project at this scale, it is important to communicate your ideas clearly between your team members and to others. And the iLab has the facilities for us to be able to do this effectively. And we were able to bring our ideas from multiple people to light with these tools. Multidisciplinary collaboration is also a very important aspect of the iLab. For this project, textile and apparel management students as well as architectural students came together to form a virtual fashion show. Textile design students tend to work very manually. They work with sketches and cutting fabric and paper to showcase their ideas. Architectural students, on the other hand, use technology and visualization techniques extensively to showcase their work. Through this partnership, we were able to let the textile design students see their work in a way which they wouldn't have otherwise. And we provided the platform and the environment which allowed them to see their work in a more immersive way.
Right. In the iLab, we could do a variety of different things. And one of those is capturing objects or flat objects with a multitude of technologies that we have. And what we have here is one of our Mizzou alumni actually came across a box of 1904 St. Louis World's Fair stereograms. And what a stereogram is, you put these images into this stereopticon here, and it gives you one image, such as you see here on my left. And by digitizing them, we're able to now watch them on modern 3D displays, such as the Oculus Rift, as we've shown here. And I said earlier, flat images and also objects. So when the Art and Archaeology Museum moved to Mizzou North, we thought this would be a great opportunity for us to come in and document their artifacts in 3D. And we did this by using multiple 3D cameras and taking pictures from different angles. And just like with the stereograms that we had from the World's Fair, we were able to now view these on multiple displays or new ones. You could watch this on your cell phone, or even if you come to the iLab, you could see it on our large 3D projection screens. So it just kind of shows you the variety of things we could do. Here we have James showing off the Oculus Rift. He was actually using this to revisit a project that he did in his undergrad. It's his thesis project, and this allowed him to be immersed in his project in a way he could never do before. And the head tracking that comes with the Oculus allowed him to more naturally explore his space and see if his design worked.
So we're not just interested in how the technology facilitates visualization. We're also interested in what the impact of this technology has for understanding space and user experiences. And the way that we've gone about doing our research in this area is we've looked at technology in terms of its key affordances. And you can see here we broke it down into the different groups. We have modality, interactivity, and we systematically manipulate each of these in terms of the technology. And then we measure their relative impact on a variety, you can see here, of user experiences. So this is 2 examples of projects that we've done in this line of research, and it is an ongoing stream of research that we're doing. This project here on the left, I believe, no, it's on the right. And it looks at the affordance of level of detail. And we've broken down level of detail in 2 dimensions. So we have a low and a high. And then we measure the people's understanding of space in terms of depth, width, and height. We built on this study with a second study where we looked at the affordance of realism. So we broke down the level of realism into 2 dimensions again, and we looked at spatial understanding, but we also added in the experience of how well people remember objects in this space. This line of research we're building slowly, but the impact of it is very important. For us, in terms of presenting visualizations to people, we want to understand, is it better if we present information on a large screen versus a small screen? This is a type of study that would help us accomplish this. It's also very important because it helps us when we go to update our technology or to invest in new technology, because it gives us a better insight into how we should go about purchasing technology for certain types of affordances and experiences. The last area that we're going to present work on today is one of our newest areas, and it deals primarily with what our department's focused on, and that is designing spaces for humans to use. In our field, most of the people, they look at, you've seen we do a lot of computer work, so we display and design environments in the computer, and we rarely focus heavily on environmental factors. And what we do next is we look at how humans use the space, but we use tacit knowledge to obtain that idea. And then we evaluate the performance of these spaces based off of that tacit knowledge. We're supposing that we can use more technology to integrate into this process. So we start out with the environmental factors with the computer models, and now we're simulating human motion with human factors, and then we can go back in and evaluate these spaces based on their performance with the visualization of human motion. And we're looking at different scenarios such as emergency crisis scenarios.
This diagram shows the workflow which we conceptualized and successfully tested with the inclusion of the environmental factors and the human factors. We use these to then simulate and measure all the ideas that we talked about. To test our workflow, we created a proof of concept in a complex scenario in which we could use a motion capture system to see how a person would interact in a kitchen. This allowed for for an ergonomic study of their movements and complex information that we could gather from it. This went successfully, and it allowed us to acquire a more sophisticated motion capture system that consisted of 12 cameras. It allows us to capture multiple people, multiple actors, and the types of studies that we can do now is exponentially improved, and the accuracy also of these studies can get better. And Mike is going to talk to us about one of those projects.
Okay. All right, here we have, with this motion capture system that James is just talking about, is one of the projects I'm working on is disaster response training, and you have me and then another grad student mapping our or recording our movements to be mapped later to these 3D models. And the purpose of this is to create a library of actions that we can later map to intelligent agents so that they can maybe act out in mass simulations or things like that. And what's actually going on here is Asan is we're imitating helping an elderly person stand up and down. And this could be used later in like a scenario or a situation. Well, if you liked anything that you've seen today, we'd really like you guys to come by the iLab on Friday and Sunday. We're having an open house between, well, let me change it so you guys can see, 11 to 5 on Friday and 3:30 to 5 o'clock on Sunday. We'll be showing off a lot of the stuff that we showed today, plus things that we couldn't. We'll have the Oculus Rift, maybe the motion capture setup, and we'd really like it if you guys came by, asked some questions, and just checked out our demos. Thank you.
We have time for a question or two, and I guess my question would be, I think if you've probably thought a little bit about this at least, how do you apply all the things you've learned to scenarios that might help journalists tell stories better?
Okay. Well, one of the things that you could do is maybe recreate historical events that you can't revisit anymore, or let's say maybe a news story, something happened, somebody got hurt, and you wanted to see how it happened from different points of view. You could recreate these in 3D and revisit these now with the Oculus Rift, with the head tracking, and different types of technology. Is that it?